Our lesson today will cover material from lesson 10. Okay, from lesson 10, and we'll do problems from that lesson 10. Now, this lesson 11, however, I don't have the lecture video for binomial distribution 6.2. So I used the one from spring 2020, last year. And let me see. I think I used the one from, give me a second. For some strange reason, this morning, I found out that this computer runs super slow. I don't know why. I really don't know why. Very, very slow. So be patient with me, bear with me. For lesson 11, the one that you need after your test. Yeah, this Wednesday we have a test, right? Don't forget. This Wednesday we have a test, and this weekend, therefore, I need you to watch this lesson 11. See, it's so slow. What happened? Oh, shoot. Well, I will update it further. But yes, today you should have watched this lesson 10, which covers section 6.1. Yes, my computer is super slow. Things that should be done can be done in 1 second turns out to be done in 20 seconds on this computer. As I know, it did some updates this morning with my Microsoft Office. And then from there on, it's effing slow, to the point that I get pissed off. So there could be once in a while that I need to restart this computer to figure out what happened. Okay, but let's do this first. Assuming that you already watched lesson number 10 from announcement number 4, then let's start with random variable. Now, what is random variable? Random variable.
Professor, I had a question.
Uh-huh.
I don't know if it would be okay if there was time to go over like a few examples for the exam, because I know I didn't do so well on it. So I wanted to see if we could go over like similar examples for this upcoming exam. It doesn't have to be the same, I know, but it could be like something similar to it, just so I can get like an idea.
Okay, are you talking about test 1 or the material from chapter 5?
No, the test 1. Like, so we could get an idea of how it's going to be.
But I went over that for a lot of times, like last week or even 2 weeks ago. Let's see. I mean, here's the thing. Asking me to do what I have done before will not be a good idea, because you can just go to our Zoom, and then from there we go to so it's super slow. I really don't know what happened with this computer. I basically already cover a lot of those. Like for test 1, we are talking about test 1. We finished material for test 1 at the end of week number 4.
It was the one we had to print out.
The one that you have to print out.
Like the page that we printed out. Are you talking about that one?
No. I'm not talking about quiz. I'm talking about I already went over a lot of problems from test ones, my old test one.
I guess her question is, we don't feel confident in the upcoming test, and can we open the floor? But I'm pretty sure that's what your 3 o'clock to 4 o'clock hour is for. But she was saying
No. 3 to 4 hours is my office hour, and so far nobody come to my office hour.
Yeah, what she's saying is
I'm sorry.
We're having enough.
I'm sorry. Repeat it again.
Instead of moving on to a new chapter, she was saying if we can focus on the upcoming test, since it's going to be the next class.
Yeah, but that's something I already, I understand, but that's something I already went over in week 4. That was something I did 2 weeks ago. I mean, I don't see the reason why then suddenly you bring it up 2 weeks after I went over that, unless you didn't watch that part. You know, if
I think I think it's more of a confidence thing and making sure that, because there was a good amount of people that didn't do good on the upcoming, this previous test. So we wanted to make sure that
the previous quiz,
your material.
The previous quiz, you mean?
Quiz, yeah.
Okay.
The previous quiz, which is going to be a collective of what will be on test 1. So I think it's more of a confidence thing for everyone, or for most.
Okay, but you need to work together with me and come to my office hour for that, though. Okay, I mean, I don't mind to do it now. But then what end up happening is this: our test is on Wednesday. I purposely finished the material for test 1 on week 4 so that you have 2 weeks to study for that. So I did expect, if you have any question, you asked me last week, not last minute, not 2 days before the test, which I don't mind to do, but at the end, it's your loss because I gave you 2 weeks to study. Now, I'm not referring to any particular students. I'm referring to this whole class, okay? The game plan is like I give you 2 weeks to study and you make it 2 days only and talk about confidence.
Well, no, we don't. We're still getting to know your class and your structure too. So.
No, not in week 6. No, it's too late.
This is the first exam, though. I agree.
It is the first. It is the first exam, but even first exam is not the place you practice to take a test. You know, week 4 is when I finish it. So I did expect you ask me a question in week 5. You know, see I will just do it. I don't mind. Okay, don't get me wrong. It
sounds like you mind though, Professor, and it's concerning because the lives are the only place where we can ask questions, and I don't even feel comfortable asking questions because you sound very upset.
I'm upset because I gave you 2 weeks to study and you just wasted.
It's not wasted. I feel I learned, but I'm still not at the point where I feel confident and comfortable taking the test entirely, especially when, I got my results from the quiz and it's not what I was expecting at all.
Okay, that's something you can just see from my lecture. Okay, now this is what I don't want to happen is this. Okay, I said it many times that I want my material finished 1 week before the test, and I was actually happened to be able to finish it in 2 weeks before the exam, so that you have 2 weeks to study. Okay, so that you have 1 week, like 1 weekend you study, and then the next week you can ask me, and another weekend you can study even more.
I don't have weekends to study. That's the concerning part. You know what I mean? Like I have limited days too, and I understand, like you said, this is a priority and I'm trying to make it, but we all have other responsibilities. And like you said, I'm not downplaying. Your class is very important to me, and I want to do well. That's why I'm reaching out to you. Like I said, I understand that you're frustrated too with, maybe it is too close to the test, but this is our situation now. And I don't want to be even further behind trying to, learn the other material and be ready for the exam.
it's a lot at once for us right now too.
Yeah, well, but the thing is, like, you know that this is a transferable course, so this course is as fast as that is. You know, I just don't want you to have the same situation in your test 2, test 3, test 4, and final.
Exactly, I don't
Okay.
either. That's why.
Okay.
That's I
So
completely
telling me that you have issue, everybody have issue. That's why I give you the recording in advance so that you can manage your time. But if you cannot manage your time, then
But-
that's another thing.
Professor, I watched the
Is it more
recordings
so
up to 2
understanding?
times. I'm not lying when I'm telling you. I spend 3 hours before even watching your live. So by the time I watch your live, it's kind of the second, almost third time that I'm watching you work these problems out. I promise you, I'm not waiting to the last minute.
Yeah, what I'm afraid is like what I'm afraid is this, like when I'm surprised because like it's already far behind my mind. It's like 2 weeks ago thing. So I can do it right now. Okay. You choose which test you want me to go over. Okay. But then by doing so, it push forward later on that we have less time to focus on our test 2 and later on even further for test 3. And we will be so much behind schedule at the end of the semester.
I mean, or is it a small group that's struggling right now, or would you say it's overall? Because I feel if it's overall, then we can all benefit from this, right?
But I have my responsibility to finish the curriculum.
I understand that.
You know, okay. So I do expect you guys in future, please be more active then, because I don't get those questions during class.
I'm following you during class. I mean, that's why I'm still, like I said, I do have questions I do ask during class, but I'm trying to just follow along with what you're working to make sure that I'm trying, that I'm understanding it properly, but I don't know.
You pick one semester in which that I have not done the testing. Of course, if your test one is bad, I may just tell you to drop the class, and I hope that's not the case, and that's why I give it a lot earlier. But I mean, if this is the case, we are not ready for test 2 3 weeks later when it is at least 2 times harder.
Right, that's exactly my concern. That's what I'm saying. And I don't want to
Oh.
feel that I'm behind on the topics, because I'm still trying to grasp like what you said like a week and a half ago. So that is a problem. And I just don't want to, I don't feel comfortable moving forward with that lag.
Yeah, I expect you to ask me that question last week, if so. Okay, bring it up. Which test you want me to go over?
I think it's just making sure that we are understanding the test that we're about to take and kind of like open up maybe half of our classes. From my understanding, this was a statistics with support class. So going over new material and also like just opening the floor and making us comfortable. Hey, I understand that you are breaking it down for us, but maybe we're just not comfortable enough to come to like, hey, can you simplify it a little bit more?
Okay, so bring it up. Which question do you have? I'm waiting for that.
Anything still related to probability and setting up questions with that. I'm still struggling with that personally.
Okay.
I don't know about anybody.
Are you talking about test 1 or probability, which is most of them, like the recent one is already the material for test 2?
Test 1 is okay. I can set up the tables and things like that. For me, it's the probability, like the questions, like as far as the questions that you had in the card, like the card questions in the quiz, those type of questions where we have to take the information, set up the problem, and then solve.
Okay, so you were referring to the last quiz you turned in. So that's, let me see. So I need to open it from my files here. So quiz 234, is it right?
Right.
Okay. And at the same time, my computer is like super effing slow. For this one, I apologize though. I really don't know what happened. So this morning with my Santa Monica class, like I only ran for half an hour at first, and then I need to restart my computer. I ran for another half an hour, and I have to restart my computer again. So if I suddenly get locked off, it's not because I get mad with you or suddenly don't want to teach. Okay, I will
okay.
log back. I will log back. Okay, it's just like
Connection's
so.
been pretty bad. Yeah.
No,
it's not
no,
just
I believe
you.
it's not. I believe it's not the connection, because I use my computer from my room, my bedroom, and it was actually totally fine. It's just this computer, this laptop. I really don't know why.
We'll work with you. Don't worry. I need you.
Yes. Okay, for that one, please. I'm very upset already with my computer, and no, it's not directed toward you.
It's probably the
Okay.
Zoom, because the Zoom makes the computers like the screen lags for a moment when you share it. So it's not your computer.
No. It's my computer. I know, because even when I start, I don't even log in the canvas yet. Even when I start, it's already like that. You know, I wish I can blame it on Zoom, but no, that's not true. Yeah, the Zoom actually working totally fine. The Zoom
There must
actually
be-
fine.
Then another issue could be dust. It could be dusty inside, like the fans.
It's all of the sudden though, because yesterday I did I helped a couple students online, right? It was fine. Just this morning when I turn it on, it says that I need to update something. Okay, so the computer is updating something, and all of a sudden my OneNote, the one that I use right now to write, suddenly doesn't work. And it's just like I basically have to go over, reinstall my OneNote, this and that. Oh man, that's so painful.
Oh yeah.
It's like, imagine if it takes me, I click this file, okay, and then I went to restroom doing my number one and come back, it's not open yet. It's like at least 1 minute, it's not open like this yet. Right now it's already faster, but earlier it was, oh man, it's like I ran out of my patience. Okay, so I guess you were referring to this number 4 CD and number 5, right? Okay, now let's do number 5 first. This number 5, we have 52 cards and 13 of them, 13 spades. Now the keyword is actually with the word different here. Different cards, so it means whatever card we get, we don't put it back to the deck. If we put it back to the deck, it may get reselected. You see? So after we pull it out, we set it aside before we take another card. So the probability to have all spade is equal to, now, what is the probability the first card is spade? How many spades do we have?
13.
Out of how many cards?
52.
52.
52. Now that's the probability to get the first spade, right? Now then you put whatever that spade aside. What is the probability you get a spade again? How many spades you have now left?
12.
Out of?
51. One less card.
That's right. And then you take that, you put that second spade card away. Now you get the third card. What is the probability the third card is also a spade?
11?
11 out of 49. Or 50.
11, 11 out of 50, that's right. And then the fourth card, how many spades left?
So that'd be 10 out of 49.
That's correct. Now, and then from here, you compute the probability. Let me use my calculator. Yeah, you will do it this way. The best way actually to compute that using calculator is you key all of them in, 13 times 12 times 11 times 10, and then divide it by 52, 51, 50, 49. Why can I not? Oh, I think I know why. Do you see that? Let me show you. Let me screenshot you what I have on my screen here instead of only the. So what happened was like I tried to click this one and it doesn't work. Is that the reason though? Not supposed to.
The delay.
Yeah, the delay is on. Oh, it works. So, but it's just way too long.
It's a long delay. That's all I think.
Yeah, it's way too long. The thing is like this computer is actually supposed to be fast. It's a laptop, but it's supposed to be fast. This is way too long. Like you can tell like in the past when I try to turn on my computer calculator, it's a lot faster than this. Okay, it's still like this. Well, I will just use my handheld calculator. Okay, 13 times 12 times 11 times 10 divided by parentheses. So on the denominator, I will show you later on when it goes up, but divided by in parentheses 50 times 52 times 51 times 50 times 49. Okay, so my calculator already on. Okay, so I will punch 13 times 12 times 11 times 10 divided by parentheses, because we divide by the product on the denominators. That's why we need to use parentheses. 52 times.
Can you repeat that about the parentheses?
Because we divide by the product of the denominator, right?
Uh-huh.
So if you don't use parentheses, then your calculator will not consider that as a division. See, if I type this 13 times 12 times 11 times 10 divided by 52 times 51 times 50 times 49. If we type it this way, then our calculator will divide 52 and then multiply the result by this. That's not what we want them to do. What we want them to do is this group here divided by this group. You see? So then divide by parentheses 52 times 51 times 50 times 49. Like that. And then I press enter. That's what I get. Okay, 0.002641. 0.002645 decimal places, like that. Of course, you can also just do it this way, like you do 13 divided by 52 times 12 divided by 51 times 11 over divided by 50 times 10 divided by 49. You can do that. What you don't want to do is to change each of them to decimal and then multiply. No, don't do that, because once you change them to decimal, you are forced to do rounding error too early.
My error was I guess I used the wrong formula. I only did 13 over 52 and I didn't do the 12, the 11, and the 10.
Yeah, I see that a lot. Actually, you are not alone. I think around half of the class actually doing so, but that's if you pick only one card.
Okay, it threw me off with the four decks. I didn't know if I was supposed to times it by 52 times 4. I got a little lost in that concept.
Do you get it now?
I'm grasping it.
Yeah, so what happened is you have a deck of 52 cards, right? You have a deck of 52 cards, then you are selecting 4 cards. Not only one, you are selecting 4 cards. Okay, what is the probability that all these 4 cards are all spade? Now, when you select 4 cards, then you basically need to select one by one, right? Now, for all of them to be spade means the first one has to be spade. What's the probability times what is the probability the second one is spade? Times what is the probability the third one is spade? Times what is the probability the fourth one is spade?
So it's individual problems. It's not all one problem in one equation. I mean, one.
You do it one by one, okay, but you multiply them. So we are doing compound event here. This is the case of compound event where it's not only doing one thing, but we are doing 4 things. Now, the question is, what is the probability for these 4 things happen at the same time?
So 4 entities working.
Yeah, so if we look back to where you should study more, let me refer you first, okay, where to study. If we go back to our discussion, let me close this one. Do you see this? That is, let me see, March the 1st. Yeah, so March the 1st was the first time we talk about compound event. So one place that you can see the lesson, you watch lesson 6 first, okay, and then you go to the Zoom and watch the recording for this March the 1st. Okay, so basically that's when we discuss compound event, where we have events, many events that we need to see they to get at once. So instead of only one event to happen, we have some events happens at the same time, and we want to compute that probability. I'm sorry with my computer, though. I don't know how. Yeah, so that's when, yeah, so this is when I start talking about compound events. At that time, we dealt with only 2 items, and then we slowly go to more and more items. Now, of course, you will continue with, I believe that's March 3rd. So on March 3rd, we have that compound event discussion again. And yeah, so on March 3rd, I went over 5.2 and 5.3, and then I did the compound event. Now, I also went over these 4 tests actually. I went over these 4 tests on that March 3rd, and then March the 8th and March the 10th. So on March 3rd, we went over these compound events. Let's see, I'm opening the preview for this. I may need to change the computer to the computer in my bedroom. So you are seeing my screen here, right? Whatever I see is what you see. Now imagine I put my cursor here. Okay, it comes down so slow. And this one is not even opening up. Yeah, compound event is one of the difficult part in test one, but not that difficult though. Of course, you need to practice and take a look on what happened there. See?
Honestly, Professor, I thought we were going to go over our quizzes so we can ask you questions. I don't know if you wanted us to wait until class and we discuss the quiz, or during office hours. I don't know exactly which one, since this was.
Oh, I said that before, that I post the solution for assignment. I don't go over that in class until after you see the solution, then you have question, then I answer that. You know, instead of me going over all of them, right? Okay, some questions you don't need me to go over them anymore. Right? Like for example, question number 1 here, like it's something we already did. Right? So I have my solution here.
Yeah, the first half of the quiz wasn't that hard.
Yeah.
Really, it's the second part that.
Yeah, the second page, as I know, is the one that yeah. So what I did is, like, after you turn it in, maybe in 3 or 4 days, then I post the solution. You look at the solution, and then if you have more questions, then I go over that. You know, yeah, that's what I want you to do. It's not that I don't want to go over the solutions. It's just like, imagine if I need to go over test 1 after test 1, right? Okay, that will be one more day. And most of them actually things that you can just see yourself from my previous lecture, my previous lesson, and when I went over the old tests, you know. So yeah, I have the solution here.
Understandable. I just didn't, when I signed up for the stats with support, I thought that was what we would be doing.
Yeah, that's the support. The support that I do is, like, I go over the material you need, right? Including all the details. But then you need to anticipate right away by doing problems, you know, not by doing problems. And then if you still have questions, you ask me right away. And that's why I have office hour on Saturday. You know, so far my office hour on Saturday only being used by those from my calculus 2. You see? So yeah, so this is the compound event thingy. Why do I need to show you this anymore? But yeah, just remember that you know how to get my lecture from Zoom, right? The one that I go on daily basis. Okay, and you also watch the lesson from YouTube.
Yes, and then print out the notes to follow along with it as well.
Okay, so you have those two. Now then, if you have questions from those, then first ask during my office hour. That will be the best. But if not, during class time like this is also okay. I'm just surprised that you asked me about test 1 2 days before test 1. I was like, what? You know,
we just got our test back over the weekend.
Your
Quiz.
quiz. Yeah, but don't wait until your quiz come back. We studied that the test
Well,
one.
I was, I guess, falsely optimistic because, like I said, I thought I knew what I was doing, and it's like, I guess it's more concerning that I thought I knew what I was doing, and I don't, obviously.
Yeah. It's now the thing is, like, I went over, as you saw there, that I went over for all test 1 already. You know, because test 1 is more about procedure and speed. You know, yeah, procedure and speed. I mean, you will have enough time even if you are slower than usual. You still have enough time. but it's more about like, do you know what to do next? Do you know what to do next? Do you know what to do next? Like that. You know, it's a lot of procedure. It's a lot of procedure, such that if you don't get used to it, it's about getting used to it. If you don't get used to it, then you will have, then even if I give you extra time, it won't be enough, you know. Yeah. I mean, in the past, I gave this case, like for test 1, the students say, oh, Thomas, not enough time. So I give them extra time, you know, and what happened? They still messed up anyway. And it's like, oh, Thomas, that's not what I saw. It's like, it's in my old test, you know. Okay, let's go on with number 2. What is the probability that all of them 4? How many 4 in a deck?
4.
4. There are 4, right? So the probability all 4 will be 4 out of 52 for the first 4. What is the probability that the second card is also 4?
3
Out of
51.
Times. What is the probability the third one is also a 4?
2 over 50.
That's right. And then last one is 1 over 49. Okay. And then from there, you use your calculator. You can see the result from the solution I post there. Okay, but the key step is actually this. This is the key steps. And you need to show me this. You need to show me this, because what you did here, what you wrote here tells me how you did it. Okay, don't just get to the number right away. Don't just get to this right away. No, I want you to show this. Okay. Now, part C, what is the probability to get Jack and then Queen and then King and then Ace in that order? Now, how many Jacks in these 52 cards? Yeah, 4 out of 52, right? And then what is the probability that the next one is a queen? And how many queen do we have? That's 4 out of 51 cards, because 1 Jack already pulled out earlier, right? And then what is the probability that the third card is a king?
So it'll be 4 out of 50.
4 out of 50, that's right. And then what is the probability the last one is an ace? That's 4 aces out of 49 cards left. Okay, then you give me the decimal. Keep in mind it has to be in 5 decimal places. Okay, then the last one, what is the probability that at least one face card, face card is either Jack, Queen, or King. At least one face card is an event, complementary event of no face card. Then what is the probability? The first card is not face. Then let's see how many face cards do we have. We have Jack, Queen, King times 4 suits, right? Okay, so there are 12 face cards. Therefore, there are 40 not face. Okay, now what is the probability the first card that you pull out is not a face card? And that will be 40 out of 52 times the probability that the second card also not face. That's 39 out of 51 times the probability the third one not face there, 38 over 50 times the last card is not face is 37 over 49. Then from there you use your calculator to compute. Then you get the answer. Okay, but you see that using calculator is the easy part. How to compute it is the hard part. That's why when it comes to probability, a lot of people see that as difficult. Okay, that's for number 5. Now let me go back a little bit to 4B, CD. So far, only one person in this class get this right. 4CD. So what happened is we have this Venn diagram, and we want to select in part C and D, we will select 3 different elements. We want to select 3 different elements. Now then, what is the probability all of them from A? Now, what is the probability all 3 elements that we get are from A? Then how many elements in A? How many elements in A? You need to know this though. Can you count it?
It's 100, right?
Only in A. How many elements in A? The number
Oh,
of
in A.
element. Yeah, number of
Okay.
element overall is 100. That's true. But how about number of element in A? How many? In A, refer to the
34.
one in here.
34.
That's right, they are 34. They are 34. Okay, so that's 19 plus 3 plus 5 plus 7. They are 34. Now then, what is the probability that all 3 elements, different elements, are from A? So the first element to be in from A is 34 over 100. That's for the first element. But then you need to get 3, right? So what is the probability that the second one also from A?
So it's again 33 over 99.
That's right. And then what is the probability the third one also from A?
3298.
32 over 98. Yeah, that's right. And then you use your calculator. Okay. Now part D, what is the probability at least one not from B? At least one not from B is the complement of known not from B. Basically, another way to say that's probability of all from B. Okay, the complement of at least one not from B, some not from B, the complement of that is all from B. Now then, let's see how many elements in B. That's 20 plus 3 plus 5 plus 8 equals to what?
36.
36, that's right. Okay, so probability that all of them from B will be 36 elements in B over 100 for the first pool. And when I get it the second time, the probability this also from B is 35 over 99 times the third one is 34 over 98. So then that's 1 minus something, right, equals to something.
Yeah, setting up these problems is usually where I'm stuck. Like you said, once I start seeing the 36 over 100 that you're subtracting 1 because it's 1 less, then I understand. But it's that initial setup.
How to set it up, and it's when it comes to probability, it's actually always like that though. It's always like that. It's like sometimes I have seen students who have this. When we did only one element, if like part A and part B, they can do it so easily and they don't even look at part C and D and study from those, you know, until they see that in the test or in the quiz. Good thing this is a quiz though, that you know your weakness before your test, right? Okay. But what usually happens to those students is like they think it's as easy as doing one element, which actually it's easy, but it's about mindset. Okay, how to get 3 elements? Well, I will do it one by one and just do it one by one 3 times like that. Okay, now the thing is, the idea of doing it one by one 3 times is not something they have in mind because they get used to do it only one time, one element. That's why we call this compound event. Compound event because that's actually you select one element at a time. You just do it many times. In this case, you do it 3 times like that. Okay, and yes, the reason I put this question last because compared to the previous page, this is actually on the easy, on the hard side here. Yeah, this is on the hard side. Okay, yeah, but oh, by the way, only one person, only the same one person get number 2 right. And 2 of you incorrectly, this is definitely not my fault. I refuse to take it as my fault. Some of you say 2% is 0.2. No, 2% is not 0.2, it's 0.02. Okay, not 0.2. Not 0.2.
I was only off by 1 0.
Yeah, you know that off 1 0 is actually a big one. Right?
That's the point. All that work for nothing.
Yeah, but yeah, so what is the probability that all this clock will all malfunctioning? So probability that all malfunction is the probability, the first one is malfunction, that's 2%, times the probability the second one also malfunction, the third one also malfunction, then that will be 0.02 to the power of 3. Okay, and that will be 0.000008. That's the probability. Now, if you round it to 5 decimal places, that will be 0.00001. That's the 5th decimal place, right? But the next number is at least 5, so I round it up to 1 in the 5th decimal place. Now, probability that at least one work is equal to 1 minus probability no work. All of them malfunction. So that's 1 minus 0.000008. Yeah, probability that all of them malfunction, right? That's something we already get from part A. Now then this is 0.999992. Or if you round it to 5 decimal places earlier, that's fine. I know where you get that number. Then your final answer will be 0.99999.
So
Okay,
that
either
question
one
is like
okay.
the complement of A?
Yes, that's right. The complement of all malfunctioning is at least one not malfunctioning. Yeah, the complement of at least one, the complement of that is none. Right? At least one work is the complement of nothing works. But when we say nothing works, it means all of them doesn't work. right? So the event of all of them not working is already answered in part A. That's what we use here.
Is that the same concept for the next question, part B, where
That's right.
Yeah, is that?
Yes, that's right. So what happened here is probability of pass the house is 0.76. Probability of pass the Senate is 0.62, and probability at least one of them, that's either House or Senate, right? At least one of them is 0.89. Now, then what is the probability that's not passing House nor Senate? Probability of not passing either one of them. Right? Probability of passing none is probability of not any one of them. So that's 1 minus probability of House or Senate. That's 1 minus 0.89, 0.11. Okay, so for this question, you can actually answer part B without doing part A. Yeah. Of course, then the concept is you need to know what does it mean to say neither House nor Senate. Neither one of them. Neither one of them, that's the same to say none. Now, the complement of none is at least one. Okay, so yes, you're right. So you notice that the idea of at least one, how to compute probability of at least one is being employed in 2B, 3B, 4D, and 5D. Okay, yeah, that's where we put it. You know what? Let me do this. So what I will do then is, instead of going over lesson 10, let's do it this way. We will postpone lesson 10 until next week. Is it okay?
Yeah, I think it's what we
Yeah.
need.
What we will do, so I will cancel this. It means on Monday next week, you have watched lesson 10, if possible, lesson 11 also. Okay, now that means you need to have watched lesson 9, 8 and 9. Okay, 8 and 9. That's this weekend, you need to catch up. Okay,
Like 9, 10, 11 by Monday. Yeah.
yes, yes. The thing is, like 8 and 9 is something we already went over last Wednesday though. So when I say I want you to review them again, my assumption is you didn't go that far. It's like means you need to watch the lesson from YouTube. You need to watch the discussion from Zoom, the recording. Okay, because there's no way we can do chapter 6.1 without you knowing 5.5, the permutation and combination thingy.
Right. And I was here live, so yeah, I did take the notes and stuff on that.
Yeah. Okay. Now for now, let's just do one more alt test, because test 1 is supposed to be the easiest one. Yeah. So test 1 is supposed to be the easiest one, and I want to make sure that you get at least 70 on that. Not getting 70 in your test 1 basically disabled you from moving even further. Do you have any semester you want me to go over?
I just want it to be similar to the one we're going to be giving, like same wording type of thing. So I know.
No. The same wording is kind of hard to get. It's not that I don't want to give you the same wording. How to say that? The cases are actually similar from one to the other. The difference will be the underlying concept's the same, but the case may seems to be very different. So let's say the case of getting elements from Venn diagram. we can suddenly change that to getting elements from contingency table and so on and so forth. Let's do it this way. Let's get the one from winter. So in the winter, let's see. From winter test one.
Professor, can you post it so I can print it out and do it with you?
Yes, let me do so. I will post it on the discussion of the day, okay?
Okay, thank you.
But you can see how slow is this. I don't know what makes this computer so slow. I really about to cry, actually. I mean, this morning I was just like this morning I felt more into like I felt embarrassed before the class because like they were so ready to do the last part for their test. Their test is next week because they start 1 week later. SMC start 1 week later, so they have their test next week, right? But today we're supposed to go over one test from the beginning to the end. You know, and then I was just like, what happened to my computer? I feel so terrible.
It could also be the memory. I don't know.
That's what I think. Yeah, that's what I think is the issue. But very likely because Microsoft suddenly updated and installed one new software that requires a big memory. That's the only thing I can think of. That's the only thing I can think of. You know, I really need to dig very deep into this though. But anyway, do you have printer? How many of you don't have printer right now?
I have.
Anybody don't have printer?
I have my printer.
Okay. What I think I will do is this. What I think is I will post it on this discussion board. Okay. And then I will log off, try to shut down whatever program running at the background. And then I log back. But in between, you have a chance to print out this test here. Okay. But,
Okay, that works. Yeah.
Yeah, bear with me. This will. Okay, me and my friend, when we talk about like how slow my computer is, we use number 1 or number 2. I say, and then in my case, I will say my computer is like as slow as number 1. Means I go to restroom doing number 1, come back, it's not done yet. The worst case is number 2. Okay, so let me post that winter 21. It's definitely something with computer, not internet. I wish I can blame it on internet, but no, it's not. It's not. Even when I start this computer this morning, I was just like, what the hell? What happened? Okay, that's from winter 21. Test 1. Okay, so I may go out for maybe half an hour. I hope not 1 hour. We need approximately 1.5 hours to do the test, right? So around half an hour. I give myself half an hour to fix whatever I have on my computer. It's already there, so please print it out and then work on that. Okay. Now I will log off, but I will leave you on this Zoom in case you want to communicate. I will leave meeting. Who wants to be the host?
I can be. I don't mind.
Who are you, by the way?
Vanessa, I'm gonna.
Vanessa, okay.
Okay, I just.
I left the recording on.
Oh no.
In case.
No, but even then, it's just wasting it because then this is all gonna post and it's just like this. Let me message him so he knows.
Yeah.
There's no, you know, I don't want nothing to be posted.
I think you can turn off the recording since you're the host.
I mean,
Okay.
we can just cover whatever you have time to do. What else can we do? We're just trying to work with it.
Yeah, yeah. Half an hour, not bad. Okay, so let's see. This is solution. Okay, did you finish the first page? Okay, let me see how many data we have here. 10, that's 77.
Yep.
So, and that's population. So capital N equals to 77. The median will be, see, for the position, you write it aside. So 78 divided by 2 is 39.
39, yes.
Okay, so data number 39 is, it should be this one, right?
Yep.
Okay, that's 63. Okay, how about the mode? Something 71.
73.5.
73.5. Oh, it happens 4 times, huh? Only one?
Yeah, I think.
64 3 times. Okay, good. So the mode is done. Okay, now, how many data in the lower half? Notice that the median is data number 39. So there should be 38 data points in lower half, right? And upper half also. So 38 data, we have 38 data here. We have 38 data here, right? Then what is the position for the median of that lower half? That's 38 plus 1 over 2. That's 19.5. So between data number 19 and data number 20. Number 19 is this. Number 20 is this. Right? You see? So
Yeah.
data number 19 and number 20. That will be 43 plus 43.5 over 2. You have to write it like this though. Don't forget. If the median, or in this case, the quartile is between two numbers, then you need to write it that way, okay? Before you compute it. So this was 43.25. Now then, how about the third quartile? That's data number 19 and 20 from the top. So there are 7 here, 17 up to here, 18, 19, 20, right? Okay, so the third quartile will be 73 point, so what happened? 73.5 plus 73.5 over 2. That is 73.5. So far, so good?
Yeah.
Now the range will be the largest number, that's 98.5, minus the smallest number, that's 7. So that's 91.5. That's the range. Now then creating frequency distribution with 5 classes. So I always give you the number of classes. Don't worry about that. So the class width will be the range, the ceiling of range divided by number of classes. That will be, I think, 18.3, right? But then it becomes what?
20.
Becomes 19. That's right. We use ceiling notation because we always round up. Okay. Now then we will start with the frequency distribution. Let's set it up first. This is the score or the grade. And this is the frequency. The smallest numbers I remember is 7, right? Now
Yes.
7 plus 19 is 26. Plus 19 is 45. Plus 19 is 64. Plus 19 is 73. Now this will be up to what here? So the first class, what is the upper class limit for the first class?
26.5 is
The one here, what do you use here?
25.
25, okay. This will be 44. Keep on adding 19. You add 19, which is the class width, right? From here, add 19. And from here, you add 19, you will get 91. Huh? Why? Something not right.
yeah, that doesn't look, that looks
Because the highest score is
98.
98.5. So where did I make mistake? Okay, 90 divided by 5, 18, 19. So 7 plus 19. 19, 19, 19.
Saying that last.
Ah, here, it should be 83 here. Should be 83 here. Not 73. See, I add 19, I add 19. So it should be, when I add 19, this is 82. When I add 19, that's 101. Ah, that's better. Okay, so now the frequency 7 to 25, and then 26 to 44, 45 to 63. So I put this first to help me counting it later on. And then 64 to 82, or up to here. Okay, and then 83 to 101. Okay. Now then, first one, there are 8. From 26 to 44, how many 10? There are 13. 45 to 63, there are 19. 64 to 82, there are 1, 2, oh, there are 30. Oh, wow, surprise. And then the last one, there are 7. Okay, now make sure you add them to make sure that you add up to 77, right? This is 21, 40, 77. Yes, we have 77 up there too. So this is the frequency distribution. I have a chat coming in. The last one is supposed to be 83. You're right. Thank you. Yeah, you're right. So I didn't see that. Yeah, if I saw your notes earlier, it would be no problem. Okay, thank you. Now then, that's for number 6. Number 7. I really want to skip this number 7 though. I wish I can. No, just do it so that you can see that we actually have enough time. Okay, so this is the X, or this is the score. And then we have the frequency. And then lower class limit, upper class limit, lower class boundary, upper class boundary, oops, and relative frequency. Okay, so this is the frequency, lower class limit, upper class limit, lower class boundary, upper class boundary, and relative frequency. Okay, the classes are 7 plus 21 is 20, plus 19, 26, 45, 64, 83. This will be 25, 44, 63, 82, 101. And the frequency will be 8, 13, 19, 37. So don't forget that you need to add the frequency and relative frequency later on. Okay, let's just do the relative frequency now. So 8 over 77, 13 over 77, 19 over 77, 30 over 77, 7 over 77, the total of 77 over 77, which is 1. Now, please, when you write your fraction, don't write it using slant. Don't write it this way. No, don't write it this way. Write it using horizontal line, something over something. Okay? Okay. At least in my class, In my class, when you write your fraction, don't use the diagonal line. The worst one is like, I have seen people writing their fraction this way, this guy, and then like this. No, that's not a fraction. Okay, that's a big no-no. A big no-no. Okay, I see that I mark it wrong. That's not a fraction notation. Yeah, this notation is still acceptable, even though sometimes I have seen people using this notation here, but the number gets really big, like 2 over 3, like that. No, it's supposed to be superscript slash subscript, like that. Supposed to be like that. Okay, so the 2 and 3 is supposed to be smaller size, not regular size. Okay, now then let's see, let's go back to the lower class limit, upper class limit. That's Mickey Mouse supposed to be, right? I really hope the first 2 columns here, the lower class limit, upper class limit, are seen to be bonus question. Okay, I just need you to know the terminology basically. And upper class limit. Okay, now then how about the upper class boundary of the first class? That will be the midpoint of these 2. Okay, what's that? 25.5, the midpoint of those 2, right? Now, they share boundaries with the next class, so on and so forth. And because our class width is 19, and you will see you just keep on adding 19. So that 19 is actually an important number though. Okay, 82.5, this is 82.5. This is 101.5, and this will be 6.5 here. Okay, now that's for the first page. Any questions so far? Hey, you know what? This is the 5th test 1 that I went over. Okay, And I went over this again. I go over this again because what? Anybody can answer me. Why do I go over this again? Because we want you to go over that, Thomas. No, because I want to make sure you get it well, you do well in your test one. Okay, so please do your best. At least make me happy. Okay, with your test one. That's the easiest test though. I really want you to do very well on that test one. Okay, you want to improve your chance to pass this class, start from test one. Okay, please promise me that one.
I
Please
mean, how
promise me.
did we do on the quiz?
Huh? Repeat again?
Overall, how were the scores on the quiz?
Repeat again? Sorry.
How did we do overall on the quiz?
Not as good. Not as good. For your quiz 2, 3, 4, right? Not as good. Most of you get only half of the possible points. But I don't worry too much about quizzes though, because we have a lot of quizzes. That's one. And second, I mean, we will have a lot of quizzes. That's one. And second, I dropped one lowest quiz, right? But the one that really hit your grade at the end really hard is actually your test. So far, I see nobody failed the class because the quiz is, how to say it better. I see nobody failed the class because they don't do well in the quiz, even though they do well in the test.
Okay, I guess but is it fair to say that I guess I'm concerned because I didn't do well on the quiz, so is that material going to be a problem when I'm taking the test? You know what I mean?
Yes. So maybe another way to say it is like the quiz makes you realize that you need to study further for your test.
Exactly, or that I'm not proficient.
Yes. At least then you find out your weakness, right? Imagine those people who don't do their quiz at all. So they don't know what's their weakness. That's actually the worst case possible. Okay, but yes, I want to say this. If your quiz is bad, but your tests are good, I see nobody failed the class yet. If you pass your tests, even though your quizzes are bad, so far, I don't see anybody fail the class. Okay, but I have seen people, they have good quizzes. That's because they work together. And to be more precise, some of them, I have taught some students actually doing this, like you do the quiz for me, and then in the test, I hope I can cheat from you, and it turns out that I cannot do that. So in their quiz, they are good, but then the test is bad, and of course, they don't pass the class. This one is still okay, even though if your quiz is good and your test is good, then you may get a B or A, right? Okay, but if your test is good, but your quiz is bad, you may end up with a C only. Yeah, of course, we prefer to have a good quiz also. But if your concern is like, Thomas, I'm not ready for tests and I know it from the quiz, then the quiz actually serves the purpose. Okay, at least to make you realize that things should be fixed. Okay, and
Well,
yeah,
usually the exams are more difficult, right? So if we didn't do well on the quiz, then
actually, it's yes or no. It's yes or no. The thing is like you don't have sample quiz to study from, but you have tests, my old tests to study from.
I guess that only exposes the people that are cheating. That's what I'm saying. But if you're doing all the work, then you know where you're at.
Yeah, there are a lot of variables though can come into play, right? It's like one case that what happened is it happens that I happen to study very, very hard, and then on the test day, I study so hard such that the night before I study so hard such that I didn't get enough sleep, and then on the test day I get really sleepy, But that's not really a good way to judge your knowledge. It's more about a wrong strategy, But at least that person still can realize, you know what? Then the day before test, I should not study overnight that I don't sleep. I still need to have enough sleep like that. Okay, but well, again, I want to go over this because I want you to do well. Okay, please give me that. Please give me that. Have I shared with you that I learned to teach from a teacher who'd been teaching for so long, and this teacher actually said this to me. on the first day of her training me to be a teacher back in Indonesia, she said this, and I respect her so much as a teacher. Okay, the second important notes that she gave me is this. The first important notes, actually, I think I said that I said that to you before. The first one is do your math. It's not read your math. So basically, when you practice, study for your math, you don't do it by reading. You do it by by practice. And she said, emphasize that to your students. Now, the second thing is the one define me as what kind of teacher I want to be. And she said this. She said this nice teacher is hardly a good one. Now, unfortunately, we have plenty of students who mischaracterize nice teacher as good teacher, but no, good teacher's not nice. And good teacher is hardly a nice one. But there's a third sentence. A good and nice teacher is, can you continue this? If you can find a nice teacher, that's usually because they want to cover their lack of ability to teach. Now, if you can find a good teacher, then he will push you to your limit and he won't be preserved as a nice teacher. But if you can find a good and nice teacher, then he or she is a hard one. Because he or she being nice and good, because he expects a lot more from you. And I am that one. Okay, I know I'm a good teacher. I still try to be nice. But one thing, if I'm nice, then I expect a lot more from you. Okay, I hope you can give me that number, a good number. At least 80, please, at least 80. 70 will be great, but trust me, you can be an average student, GPA 2.5, and still give me 80 or more. Okay, please do that for me. So I copy from the frequency distribution we get from before. Okay, this is 25, this is 44, 63, 82, 101, and I think this is 8. The first one is 8. What else? 13, 19, 37. 13, 19, 37. A total of 77. Okay, now what is the next one? What should be in the next column?
XI.
X subscript I, and then what is in the next column?
X sub I.
F times X sub I. What is in the next column?
xi squared.
Xi squared, that's right, X subscript I squared. And the last column is
XI squared.
Fxi squared. Good. Okay, now then we get the midpoint. Then 7 plus 25, 32 divided by 2 is 16. And I can just add by 19 all the way because the class width is 19, right? So what happened is the the distance between the midpoints of the classes must be 19 also. I need to go lower. That's 73 here. And then this is 92. Now then multiply by the frequency. 8 times 16 is 128. 16 squared, 256. 8 times 256 is 2048. 13 times 35, that's 455. And then 35 squared is 1225 times 13. You do this together with me. Don't just look at what I do. You try to do it also. Okay, because in 2 days you will do it on your own. Okay, this is 54 times 19. That's 1026. 54 squared, 2916 times 19, 55,404. 30 times 73, 2,190, 73 squared, 5,329 times 30. Oh, that's a big one. That's 159,870. Okay, the last one, Thomas. 644. 94 squared times 7, 59,248. Now I need to add, I wonder if you still remember the coloring. This is the first number, the sum of fx, the second number, the sum of fx squared is the third number. I need to add those numbers. This is 4,443. And that one is okay. Please let me know if you get something different or if you get the same to confirm my work.
I got the same.
All three numbers?
Let me check the first two. The last one's the same.
Okay, yeah, very likely the middle number also true.
Exactly.
Yeah, yeah. Okay, so is it population or sample? Oh, it's population. It's population. So in this class, if I want to find the population mean mu, that will be 4,443 over 77. 4,443 divided by 77 is 57.701. They say round, I say that round the final answer to 3 decimal places, right? So you can just make it 3. If I don't say round to how many decimal places, then assume 5 all the time, okay? Assume round to 5 decimal places if I don't say anything else. And then about the variance, that will be, tell me what to write.
So it's going to be the 77
times
the 292,495,
292. That's right. And then minus,
the 44,43.
Square.
don't forget the square. That's right. Over
77.
Squared, because that's population, right? That's population, so that's 77 squared. If that were sample, then the denominator will be 77 times 76. So then this will be divided by 77 squared. I get, this is 469.19649. I'm sorry, 49. Now then I will do square root from here. Okay, square root, then this will be 21.661 if I round it to 3 decimal places. Okay, now I make it 5 decimal places for my variance because I know I need to do to square root that in the next step. Okay, now then from number 8, what is the interval within twice standard deviation of the mean? So the lower fence will be the mean minus twice the standard deviation, which is 57.701 minus 2 times 21.661. I get 14.379. The upper fence will be the mean plus twice standard deviation. That's 57.701 plus 2 times 21.661. Let's see, what's that? That's 101 something. So the usual interval is from 14.379 to 101.023. That's the usual interval. Now then, what's the outlier? Up to what? The lower fence is what? 14.3. Oh, wow. So the outliers are these numbers here. These are outliers. Oh, I hardly find so many outliers.
What's anything under the 14?
Yeah, anything outside of that interval 14 point something, right? That's 14.3 something up to 101 point something. Okay, so you see that that interval actually covers from here all the way to including 98.5. So this 98.5, even though you can say that he or she may be very well prepared, but he is not, that person is not considered unusual. You know, the one unusual are the one I mark in yellow here because they are outside of the usual interval. They are more than twice standard deviation away from the mean. Notice that the mean is from this whole data here. It's not pre-decided by Thomas. and the standard deviation also from the data, not pre-decided by Thomas. So the outliers are 7, 9, 13, 13, 14. The outliers are 7, 9, 13, 13, 14. Now, some people say, some instructors say you can just write the 13 once. Some instructors say you should write it twice. Either way is okay. Now, but I write it twice. Okay, I will write it twice. Now, so this will be the usual interval, twice the standard deviation away from the mean, and this is outliers. Okay, now of course you need to show this also, right? You need to show that. I strongly suggest you that between now and Wednesday, create some cheat sheet, okay, and print out the solution I have. Okay, so beside this, later on, you also have the solution from my previous test that I post, I think on March the 3rd. I think on March the 3rd, I have some solutions that I post already. Okay, so take a look, okay? Let's go on with number 10. Data set on page 1 contains 40 females. Okay, well, we remember that there were 77 people there, right? And equals to 77. Now then, of these 77 people, 40 of them female. Remember, Venn diagram always start with a rectangle. Always with a rectangle. So some of them female, there are 40 female. And the other part, the other group is those who take final. So these are the one taking final. Now there are 40 female students, 15 of them took final. So 15 female took finals. Okay, so how many female only?
25.
25, that's right, because the total of for female should be 40. And then only 12 male students took the final. So what should I write here?
3.
No.
Oh, I'm sorry. Only how many?
No, that's 12. That's 12.
Oh, that's right.
Yeah, because it says that 12 male final, right? So the number of students who is not female, outside of male, female, and inside the final, there are 12 of them. Okay, now then, what is the number out here? Can anybody help me?
37.
37? I don't think so. No, I don't think so. How many people inside the glasses? So 25 plus 15, 40 plus 12 is 52.
18.
52.
25.
25. Why 25? That's right,
Because
25. But
77 minus 25 minus 50 minus 12.
that's right. So the total inside the glasses is 52. So to make it up to 77, there are 25 students. Can you tell me what these 25 students represent here?
Male and
One
did not
student.
take the final.
Yeah.
That's right. That's the number of male not taking finals. That's correct. Okay. It's just happened that this 25 the same with that 25. Right. If I really want to manipulate the numbers, then I don't like this because there are two 25s there. Okay, but this is just what I get from the data. So write the notation, compute the probability of selecting male. So outside of female, who not taking final. So outside of final also. Oh, that's the 25 we talked about earlier, huh? That's 25 out of? Out of what?
77.
That's right. That's right. The probability to select male who did not take final is 25 male not taking final out of 77 students in total. Part C, write the notation and compute the probability of selecting a female, or someone who took the final or final. That will be, it's either female, that's 25 plus 15, that's the 40 female, plus those who take finals, which is 15 and 12, right? But we already count the 15, we just add the 12. That will be 52 over 77. Okay, now don't forget that you still need to write the notation also. Okay.
So we just leave the fraction like that. We don't do anything else, right?
You can make it decimal if you want. Yeah, you can make it decimal if you want. But at least do that first. Okay, at least do that first. I didn't say that you need to make it decimal, right? So you can just leave it in fraction.
Okay.
Is it okay? Mm.
Yeah, it's fine. I just wanted to make sure.
Good. Now, next question. Let's see. Suppose we have these. Now, use proper symbols and compute the mean and standard deviation of the data. Is this population sample? Is this population or sample? Example, how, yeah, our friend Regina says it's a sample. How do we know it's sample? I don't see the sample word there. I don't see population word there, Thomas. So how do we know it's sample? Yeah, because it's small n, it's lowercase n. That's right. It's lowercase n. Okay, it's lowercase n. Okay, that's sample size. So that's very, very detail oriented, huh? Yes, the way you write your n tells us if it is sample or population. Here it is sample. Now then, the mean will be sample mean, x bar, that is 4,447 over 77. That's 57.75325. Notice I didn't say round to how many decimal places. So assume it's 5 decimal places. Sample variance will be 77 times 294 point, I'm sorry, 141.5 minus 4447 squared over the denominator for sample variance is n times n minus 1. Okay, now I would like you to compute that. Use your calculator. Make sure you know how to use your calculator to compute that. This is the last chance for you and me. If anything that we missing, we fix it today.
I had to learn how to compute that this week.
Okay, compute that. Compute the top first. And then you divide parentheses 77 times 76. But compute the first, the top one first. So let's see if my calculator can work fast enough right now. I do one of the craziest thing possible to a laptop. I uninstall my antivirus. That's honestly crazy.
To try to make it go faster, right?
Yeah, because it seems like what I think happened was my Windows actually have an update. At the same time, my antivirus also have an update, but that update was done after the Windows being updated. Usually supposed to be the other way around. So what happened is my antivirus still using how to say that, the pre-updated Windows. So there's something not really working well together in the background. I cannot get rid of my Windows, you know. It's still quite slow though. Let me give the full better screen now that you can see my calculator also. See, 490 95804. It should be 05, by the way. Myra?
Oh yeah, I forgot to
Right?
round
The
it up.
next number
Yeah.
is 5 or more. Okay.
Yeah, I got it.
That's good. At least it's just a rounding error. You know how to punch your calculator already. Okay, so how I will punch it on my calculator, this is what I do. I usually compute the top one first, 77 times 294,141.5. Still slow, huh? And then minus 4447 squared. Then enter. So this is the result from the numerator. Now divide it by the product of 77 and 76. And I get, yeah, that's the one. Okay, so yes, 490.95805. Then from there we do the square root. That gives us 22.15757. Okay. That's for number 11. Are you okay?
Yeah, just
Got
since
it.
last week, I've been trying to get that step to be faster so I can do it.
Yeah. And then we go on to, let me change the view. Then we go on to number 12. And here it says, leave your answer in simplified fraction. Okay, what do you think we need to do first here?
Add the total population.
Find the total number of elements, that's right. So what is the number of elements in here? I get 100. Please confirm that.
That's what I got.
Okay, so what is probability of B? In B, 24 plus 12 plus 3 plus 5 over 100. That's 44 over 100. 44 over 100 reduced by 4, I get 11 over 25. And let's go on with part B, intersection of A and C. Anybody can help me?
Sorry, 9 and 3.
9 plus 3, which will give us 12, right? 12 over 100, but we can reduce by 4. That's 3 over 25. Okay, how about part C, B union C? Now tell me what numbers to add.
3 and 5.
That's intersection.
It's going to be, what is it? 25, 24, 12, 3, and 9.
24, 12, 3, 9. You may want to consider doing it in order, like you do the B first and then include the C, or you do the C first, then include the B. What you did here, I see what you did, and that's okay. So you add this and this and this and this and this and this, right?
Mm-hmm.
Okay, but I tend to do B first and then I include the C. But you can do it this way also, though. You just don't want to miss any numbers. That's the silliest thing to happen. It's silly because you know what to do. You will do it right, but you just happen to miss one number. Man, that sucks. Right? Well, we don't want that to happen. But this is okay. This is okay. As long as you don't miss any number or you don't double on any number. So when I add this, what do we get? 49, 61, 73.
Professor, can you show us how to do the shortcut on the reducing of fraction when you have one on the
Calculator?
Yeah, please.
Okay.
Thank
Sure. Let's see.
Is that the one where you press like math and fraction on it?
That's right. Huh? Yeah,
Oh,
that's right.
Okay,
So,
that's fine.
yeah.
There's so many buttons on here.
You just have to input. You just have to input your result and then like click on math, and then it'll show like fraction number 1. So you hit enter.
Okay, got
and then enter again, and it should give you the total. Yeah.
I see it there. Thank you.
Yeah, no problem.
So 73 over 100. And then go to math. And then frac, convert to frac, enter. Yeah. If that fraction is the simplest, then it will show the same. Like this. Okay?
Okay, thank you.
Sure. Let me change the view to the notes view. Then at least with this computer makes me feel that I'm not that old yet. You know, to be honest with you, Yeah, it's like if you got frustrated with someone else being too slow, it's supposed to be seen in a positive view that at least you know that you are not that old yet. I just try to fan out my frustration, to be honest with you. I get so pissed off with this computer. Yeah, okay, now how about part D? Not A but B. Not A outside of A but inside of B. What will that do? Which numbers are those? Outside of A, inside of B.
Is
Inside
that
of
24 and 5?
That's right. Yes, that's right. So outside of A refers to these, right? Those are the one outside of A, and the one inside B. The one inside B are these. Now, because it's an N, it has to be double shaded. The one that you double shade. Okay, so yes, that's the 24 and 5. Okay, so we will, let me erase this so that don't confuse me with my later computation. So that will be 20 plus, sorry, 24 plus 5, huh? 24 plus 5 over 100, that's 29 over 100. Let me make sure that's the number. Yeah, that's right. Okay, now you do this. Probability of B or not C. Okay, can you tell me what numbers to add? Start with the B first. It's an OR, right? So as long as it is in either one of them, you count it in. Now, how many elements in B?
So they have to be inside like a B, right?
Inside of B.
So it'll be 24, 5, 3, and 12.
24
Or-
plus 5 plus 3 plus 12. That's right. Now then, include the one not in C. So we already count the ones in B. Okay, there are those many elements, plus the one outside of C's. These are outside of C's, but some of them already counted. So I just need to add what more?
13 and the 14.
13 and 14, that's right. Okay, over 100. Now help me counting those, adding those. Forty-four, 57, 71. Yeah, I get 71 over 100, but I don't use calculator. Let me know if I don't do it right.
Got 72.
You get 72?
I could be wrong.
No, both of us can be wrong.
That's 71.
You get 71 also? Okay. Okay, good. Now, so Thomas, how will you penalize me if I show that and then I say this equals to 72 over 100? What if this is what I write? What if this is what I write?
You give us partial credit, correct?
Oh yeah, I give you partial credit.
Yeah, because I did that.
I give you partial credit for this. Okay, but I will penalize you 1 point instead of only half point. I penalize you 1 point that is coming from half point because you added wrong. and another half point because you don't reduce that.
Okay.
You see? Okay. So you see that the way I do my grading is more into your work, and I will give you partial points for things that you did right. Okay. Now the thing is, I have seen people, they don't write anything but just this right away, but they wrote 72 over 100. It's just like, no, that's totally wrong. Okay. Now, the thing is this. What happened is instead of 29 over 100, you write, so 24 plus 5 over 100, and you say this is equals to 31 over 100. How many points will I deduct here? If this were what you write, if this is what you write, then I will penalize you only half point because you did this part correctly. This is just miscomputation. Okay. Now, but Thomas, why don't you penalize me for not reducing? You did earlier for part E. Why don't you do that right now?
But it's part of the instruction, right?
Yeah, you're supposed to reduce that, right?
Okay, it's at the top, so.
Yeah, but why I don't penalize you for not reducing it? Okay, let me tell you, because it's not reducible.
The answer is still technically correct.
You did the work correctly. You did miscomputation after that. But from your miscomputation here, you cannot reduce this further anyway. So I cannot penalize you for not reducing because that's not reducible. Does it make sense? Okay, so if that's what you write, I will penalize you half point as opposed to part E earlier when we hypothesized if you wrote 72 over 100, then I penalize you 1 point, right? Now the half point because you add that incorrectly, another half point because you didn't reduce. Okay, now tell me part F. Probability of selecting not from A and not from B. I can help you with over 100. But that's all. Tell me the rest.
Would it be the 20 and 13?
So I will add 20 plus 13. That's right. Yes, that's the one. Those are the one number of elements outside of A and also outside of B. And we cannot simplify that or anymore. So that's the furthest we can go. How about not B or not C? This one is hard. Probability of not B or not C. Outside of B or outside of C. Because it's an or, then any number that you shade, you will add. Outside of B, that's 20 plus 13 plus 9 plus 14. That's outside of B. And then outside of C, that's not counted yet, are 12 and 24 over 100. Is it right?
I get confused on these because to me, 24 and 12 is in B, but I thought we weren't doing anything inside of B.
It's an or. It's an or. So it's either outside of B or outside of C. So the reason we include 12 and 24 is because it is outside of C.
Oh, because it satisfies either or.
Yes, it's an or, right? Yeah. So as long as it satisfies outside of B or satisfy outside of C, you will count them. If the question were B intersection C, the probability of B intersection C, then you will only use 13 plus 14. It has to be outside of B and outside of C. You see? Okay, so it's about OR here. If it is an OR, then as long as it satisfies either one of them, you count it in. Okay, let me paste that here.
So, Professor, I have a question. Technically, you can look at the Venn diagram the same way we look at the contingency table, right? Like
That's right. That's right.
if the contingency table like makes more sense for the way that it's structured than the Venn diagram. Conceptually, it means the same thing, right?
That's right. Each of them has its own strong point. Let me finish this first. Okay, let me finish this first. So this is 33 plus 33 plus 36. I'm sorry, 23. So that's 92 over 100. Reduced by 4.
It'll be 23 over 25.
That's right. Thank you. Okay, so that's for part G. The difference, the strong point of this Venn diagram is you can deal with 3 different groupings. So let's say the A is male and female, the B is, let's say they take math or not, and then the C is full-time or part-time, full-time or not full-time. So the thing is with contingency table, okay, you have only 2 groupings. Actually, you have only 2 groupings here. The first one is the level of technical writing, but each level, I mean, the levels of technical writing, but there are more than 2 levels. And then another grouping is what major they are in, and there are more than 2 majors here. If we try to do Venn diagram with this, notice that Venn diagram can only do STEM or not STEM. You see?
Yes.
Right? Expert or not expert.
Mm-hmm.
Right? Yeah, so that's the weakness of Venn diagram. Even though there's actually a way to massage that, but it's actually on the harder side. You know, eventually it will just come out as a contingency table.
Okay.
You know, however, contingency table cannot deal with 3 different groups. You see that if I try to also distinguish number of male and females, it's not doable anymore here. Right? You cannot extend this contingency table becomes 3-dimensional table, right? Okay, that's the weakness of contingency table. Yeah, each one of them has its own strong point and weak point. If I can choose, I prefer a contingency table. You know, but the thing is like contingency table don't really help us in later on when we do what they call Bayes theorem. You know, let's add this first. This is 35, 43, and then 61, 68. This is 60, 70, 70. This is 80, 88. Oh, okay. Here, 15, 26, 64 here. That's 62 plus 70. That's 132. 15 plus 40 plus 18. That's 73. When I add, this is 9, 16, 269. So when I add this way, I get 269. But let me confirm by adding this way. Hopefully we get the same number. If not, then one of them wrong. That's why since the beginning, it's better for me to just use calculator right away. Oh yeah, it's 269 also. Okay, now I will go on with if a participant is randomly selected from that 269 people, write the notation and find the probability of selecting a non-STEM major. Leave your answer in 4 decimal places. So notation, probability of not STEM. Let me just do it this way. This is 1 minus probability of STEM. That's 1 minus 64 over 269. That's 1 minus 64 over 269. That's 0.23792. So I get 0.76208. I just need 4 decimal places. 2, 1. And part B, probability of intermediate. And interdisciplinary. Can you help me? What's this?
So would that be the 21?
21 over? over 269, right?
Yeah.
21 over 269 is 0.0780781 if I do it to 4 decimal places.
I want to talk to you real quick. I told her, but she just wants to say hi. She's right here.
Okay, part C, probability that it is social science or beginning level. Okay, social science, this is an or. This is an or. So it's social science, this guy here, or beginning level. Right? Okay, you can add those 6 numbers, or you do the total of this horizontal one is 132. The total of this vertical is 68, but you need to subtract by double count 42.
Okay, so you just subtract where they intersect.
Yes, yeah, because the intersection where they counted twice, right?
Right.
The 42 is counted twice on 132 and 68. So I will do this 132 plus 68 minus 42 over 269. So 132 plus 68 minus 42. That's 158 over 269. That's 0.58736, so 74. And in part D, probability of social science major outside of known expertise, outside of known. Social science, but not known. Social science are these. Okay, but outside of known. So you cross that out. That will be Let me add them one by one. That will be 42 plus 38 plus 32 over 269. That's 112 over 269. Then you use your calculator. That's 0.41635. 4 decimal places, 4164. Okay, part E. Probability of selecting somebody with non-STEM, and no technical expertise at all. What are those?
So would that be everything outside of STEM and the expert column? So the first horizontal and the one before the totals vertical?
No, you're thinking too hard. It's an intersection outside of STEM and no technical expertise at all. So outside of STEM refers to these. These are outside of STEM. Okay, intersect with no technical expertise at all. This one.
Wouldn't an easy way to be like 132 plus 173 minus the 20 and the 15?
No. No, you're thinking what? This is not union.
Oh, okay.
This is not union. It's intersection. It's easier than what you thought. It's the if that's union, then we have some numbers to add. Yes, I will add 132 plus 73 plus 43 minus 20 minus 15. But that's a lot. Okay,
So,
this is intersection.
because
So
it's outside of STEM, it's just the 20 and the 15 then.
Yes, outside of STEM, but inside of non.
Correct.
Right? Yeah,
Okay.
outside of STEM, inside of non. So that will be just 20 plus 15. 20 plus 15. But don't forget to always divide by the
269.
number 269. Because you cannot say 20 plus 15 equals to what? Probability cannot be more than 1. Okay, so that's 35 over 269. What's that in 4 decimal places? That's 0.1301. Now I get a smaller view here so that we can still look at the table. Okay, part F. If 3 participants are randomly selected from that group, find the probability of selecting blah, blah, blah. Now, the question is it with or without repetition? Is it with or without replacement? And you need to get 3 participants. If you do it with replacement, like whoever you choose, you put that person back, it is possible you end up with only 2 participants and one of them selected twice.
But we're
Right?
not doing that, are we?
No, that's
one?
not. Yeah, for this
Okay.
one, no, we are not doing with replacement. We use without replacement. Now, the reason is again because if you do it with replacement, you may end up with only 1 participant selected 3 times. That's not
Right.
what we want, right? Okay, we want 3 participants. So what is the probability to get 3 interdisciplinary students? How many interdisciplinary students? 73.
23.
So the first student, the probability the first student is in disciplinary major is 73 over 269. That's for the first one. And what is the probability? The second one also interdisciplinary.
So 72 over 268.
And then
71 over 267.
that's right. Now then let me ask you to compute that. Yeah, tell me what you get. I want to check if you still remember how to use your calculator.
Zero 0.0193. Oh, that's going to be 4.
0.019384. That's right. And remember, when you do your decimal, if there's no number to the left of your decimal point, then you need to use that leading zero. You remember that one, right? Don't do this 0.0194. Okay, I will
Yeah,
penalize you
leading
half point for that. Yeah, the leading zero. Okay, the leading zero. Trust me, I have seen so many people making silly mistakes because of that, and I don't want that to happen. Okay. The thing is that silly mistake in reality turns out to be some casualty. Just tell you some reasoning behind why I emphasize that. America is the one of the very last countries in the world that emphasize on leading zero. So let's say in the past we write 0.1 this way, right? Let's say 0.15 this way, okay? While it's supposed to be 0.15, right? Now, what happened in the past was some research around 15 to 20 years ago, some research in the nursing department shows that a lot of nurses actually inject incorrect dose to patients because doctors wrote 0.15, and when they use copy machine. Okay, let's say the copy machine is old already, right? So
They always are. Yep.
yeah, so it looks like 15 right now.
Yeah, that's why I use zeros. I
Yeah,
know about
you
that.
see? Yeah, so that's why please use leading zeros. Now, the thing is this though. By the time I was told that America already changed to the style that you need to write leading zeros, that's because in the nursing department of Kaiser Permanente, they found there were 7 casualties caused by that. When they did research, okay, they tried to find out where the mistakes actually start. How can the nurse inject something wrong? And the nurse say, I saw 15 there. And then the doctor say, no, I wrote 0.15 there. Okay. And then it's, of course, we can say it's a silly misunderstanding, but that if you tell the victim's family and you say it's just misunderstanding, they will be yelling at you because your silly mistake between doctors and nurse caused some people die. And for that reason, then Casa Permanente start voicing that to their nurses and doctors. Okay, if you don't see that zero, then you call your doctor. If you are not sure what's that, call your doctor. Okay, so the doctor, of course, at first kind of like, some doctors are quite arrogant, right? So when they write these, doctors say, don't you see that's 0.15? And the nurse will correct the doctor. No, I see 15. Your decimal point may be just like some dot that happened to be there. I don't know. Okay, so at least then they found out kind of like a self-correcting method. You see what I mean? And of course, we don't want that mistake happen to us. Before that happens to us, let's at least discipline us not to do that mistake ourselves. Okay, now part G, 3 not expert level, not expert. Not expert. This is the expert level, right? Now, how many not expert level?
269 minus 68. I'm sorry.
269 minus 88. Yeah, so let's write it down. 269 minus 88. 269 minus 88 is what?
181.
189?
180.
Oh,
It's
181. Thank you.
181.
181. So that's the number of not expert. Okay, so what is the probability that all 3 of them not expert? It's 181 over 269. That's the probability the first one not expert. The probability the second one not expert is 180 over 268. Right, and then the probability the third one is not expert is 179 over 267.
Oh, okay. I stopped at the first one. I don't know why.
Yeah, 3 students. We have 3 students to all 3 of them to be non-expert.
0.2878.
0.2878. Hold on. Why I get something different?
77. Sorry. Maybe I'm
Like I get 0.30297.
That's what I got.
okay, maybe
Yeah, so in 4 decimal places it will be 0.3030. Right? 0.30297. Right? Okay, so it becomes 0.3030. Okay, the last one from here, at least one from social science major. Probability of at least one from social science is the complement of no social science. That's 1 minus probability of no social science. So what is the probability you get from outside of social science? How many social science here? 132. 132. 132. So the number of people not in social science will be 269 minus 132. I tried to squeeze everything in. That's what happened. Give me a second. Outside of social science will be 269 minus 132. That will be 137. Right? So there are 137 people not in social science major. Okay, so probability of non-social science will be outside of social science times outside of social science times outside of social science. And we need 3, right? Okay, now then we compute that. I get 1 minus the product of that, I get 0.130675. So 0.7. Do you get the same thing? Please check my work.
Yes, I have the same thing.
Okay, thank you. Now the last question. Almost done. Okay, so number 14. I know this is the last question because that's always my last question. Okay, so probability of A, probability of B, and probability of union. I need to find the probability of intersection. Oh, okay. So we use the inclusion-exclusion formula. Write down the formula first. That's your 1 point. And then plug in numbers. Compute the 1.39 minus probability of D intersection. So probability of D intersection will be 1.39 minus 0.97. I get 0.42. Okay, so the breakdown is the following. This is 1 point. Plug in number and do little computation is another 1 point. Solving equation, that's another 1 point. Okay, that's what those 3 points for. Okay, again, when you practice at home, keep in mind the number of points for that question tells us the maximum number of minutes you're supposed to be able to do that problem in. Okay, in real tests, however, you have more than 105 minutes though. You actually have 120 minutes in your real test. Okay, but it would be nice if you can finish a bit earlier and then do check, right? But also from here, you see that I did this quite relaxed, right? And notice that I start working on this at 5:20, as I remember, right? 5:20. So including teaching you this and that, going a bit slow here and there, I only use 1 hour 40 minutes. What I want to emphasize to you is you will have enough time as long as you study.
I guess that's just a fear I have.
You will have enough time. I emphasize that a lot because plenty of you, especially long time not doing math, you have that, yes, the fear of taking math, right? So you get anxious when you take the test. Okay. Now, by going over this old test, this is the 5th time I'm going over this. I want to show you again and again that you should not worry about time. As long as you are well prepared, you should be okay. The worst case, one of the worst case that may happen to you is you study so hard and then during the test, you get so anxious that you could not even breathe. You know, if that's the case, I really don't know how to help you, you know. Okay, I may be able to see that on my screen. If I see, oh, you know what, it seems like you kind of get stuck. So I may talk to you, hey, you know what, take a little break. Take 5 minutes break, go around, go smoke, go to restroom, do something, wash your face, and then come back and do this again. Okay, but the thing is sometimes I don't realize that either. You know, especially if I have too many students. Now your class, I think I have only 18 students. I don't know if all 18 will show up to take the test though. Very likely only 12. So yeah, make sure that you realize that you will have enough time as long as you are well prepared, such that your test one is supposed to be the place where you show off. And I use the word show off purposely. That's your test one supposed to be the place you show off how much you have studied. Okay. And show to me that you study enough and you can replicate what I do here, even though we change the context. Even though the context, the wording seems to be different, but the underlying concepts are exactly the same. Okay. That's for today. Then let me stop the recording.